Now let me explain a rule of thumb here. If something and something else happens, then I multiply. Okay, so like in our Euro Millions, I had to do this and that, so I was multiplying two combinations. So in probability, when you want to know the odds of something and something else happening, you multiply. When you want to know the odds of something or something else happen, then you add. Okay, so let's say you roll a die. I don't have a die here now, but let's say we have a die, a ordinary six-sided die. Right, what are my odds of rolling a sixlet? Well, that's 1 out of 6. Okay, what are my odds of rolling an even number? My odds of rolling an even number, well, I could roll a 2, or I could roll a 4, or I could roll a 6. These are all the different ways I could roll, and I say or 2 or 4 or 6. Okay, my odds of rolling a 2 is 1 over 6, plus my odds of rolling a 4 is 1 over 6, and my odds of rolling 6 is 1 over 6, which is 3 over 6, which is 1 over 2, which is 50%. My odds of rolling an even number is 50%. Okay, now another formula that is quite handy is the probability. This time I mean the probability. The terminology and the notation is a bit confusing. This is not the P for permutation now, this is the P for probability. So the probability of X happening, X being anything at all, it doesn't matter, this is a very general formula, is the number of ways X can happen over the number of ways. How would you phrase that? So another useful formula is the probability of X happening is all the number of ways that X can happen over all the possible things that can happen. Okay, so an example is, we take this again, what is the probability of me rolling an even number? Okay, so the probability of me rolling an even number, how many different ways can this happen? Well, 3 different ways. I can roll a 2, a 4, or a 6. What are all the possible things that can happen? Well, I can roll a 1, 2, 3, 4, 5, 6. So there's 6 different ways it can happen. So this is a different way of getting the same result. Okay. So now let us consider poker. So the dealer will deal 2 cards face down to me and 2 cards to the villain, okay, out of his deck of cards. Okay, what are the odds that he's giving me 2 aces? Okay, that's what I want to know. What are the odds when he deals a card, deck of 52 cards, he's giving me 2 cards, he's giving the other guy 2 cards, I don't know which ones. What are the odds that I get 2 aces? Okay, so probability of I get dealt 2 aces. Well, I'm going to use this formula here. Okay, what is the probability of X happening? The number of ways that X can happen. How many different ways can I be dealt 2 aces? Well, there's 4 aces in the deck, and I get dealt 2 of those. So it's combination 4, choose 2. And what are all the possible things that can happen? Well, I will get 2 cards out of 52, out of a deck of 52. So 52, choose 2, okay? And when you work this out, then you get 6 over 1326, which is 1 over 221. These are my odds of being dealt 2 aces. Anytime I play a game of poker, I have 1 over 221 chances of being dealt 2 aces. I get dealt 2 cards. The villain gets dealt 2 cards. Then you have 3 cards, and I'm not going to explain all of the rules of poker. I'm going to explain just enough to make the point about the probability. But those 3 cards are known as the flop. Okay, so basically you get dealt 2 cards each. There's a round of betting. Then you have the flop, which is 3 cards face up. Those are face down. 3 cards face up. Then you have the turn, which is another card face up. There's another round of betting. And then you have the river, which has not been dealt yet, but this will be the river. Right, I want to know what are my odds of making a flush. A flush is when you get 5 cards of the same suit, not in order, okay? 5, let's say 5 hearts in this example. So let's say that here's a heart, here's a heart, here is something that is not a heart. I don't care what it is, it's just not a heart. I was dealt 2 hearts, okay? So I have a heart here, a heart here, a heart here, a heart here. This is 4 cards I can use to make a flush. If this is also, by the way, this is also not a heart, okay? If the river comes out a heart, I have a flush. Otherwise, I don't. The next card that the dealer deals is a heart. I will get my flush. What is the probability of me getting a flush on the river? Well, there's 52 cards in the deck. I know 1, 2, 3, 4, 5, 6 of those cards. 52 minus 6 is 46. I know that there's 13 hearts in the deck. 1, 2, 3, 4. I know 4 of those 13, so that's 9 hearts in the deck. So 9 over 46, and if you work this out, this is 19.57%. Those are my odds of making a flush on the river. Now, this is the correct result. I'm hearing people screaming at me because, hey, the villain has 2 cards. Should I not take that into account? No, I should not. The reason I should not is because this information is not known to me. Okay? Now, look who's over here. Over here we've got Superman. Superman has X-ray vision. So he looks at the cards of my opponent and he says, oh, this guy has got the ace of spades and he's got the ace of clubs, let's say. So now Superman thinks, I know 1, 2, 3, 4, 5, 6, 7, 8 cards. So this is the odds of me making a flush on the river according to Superman. And he thinks, Okay, he knows these are not hearts, so we still have 9 hearts in the deck over. So according to Superman, the odds are 9 over 44. He has different odds because he has more information. I don't have that information. As far as I am concerned, the Ace of Spades could come on the river. I don't know what's over there. I think the Ace of Spades could come up on the river. So that has to be reflected in the odds that I calculate. Right? The odds ultimately are dependent upon the amount of information that you have. Right? If I somehow knew that the top card here is a heart, well then I know I have 100% chance of getting my flush. Right? But I don't know what the card is. So I have to calculate the odds based on the information that I actually have. I don't know those cards, so they don't come into my calculation. Okay? So again, this is the correct calculation because I can account for 6 out of the 52 cards. Right? Okay, now what's my likelihood of making a flush with 2 cards to come? Still the same deal at this time. I get 2 cards, 3 on the flop. He got 2 cards. I don't know which ones. But now we've only played as far as the flop. Okay, so we've been dealt 2 cards. There's been a round of betting. There's a flop. Now there's another round of betting, and I have to estimate my odds of making a flush. I have 2 hearts. There are 2 hearts on the flop, and this is some card that is not a heart. Okay, so there will be 2 more cards coming. What are my odds of making a flush by the river? Okay, by the time we get to the river, what are my odds of making a flush? Of course, a card could come up on the turn. I have my flush straight away. A heart could come up on the river, or they could come up on both. I don't know what's in a deck of cards. Right. So how do I calculate that? Flush 2 cards. So let me first do it the wrong way. So what is that? First time I have, how many cards still in the deck? 47, right? 1 card less has been dealt. 9 hearts still in the deck. I multiply with the odds for the river now. Will there be 1 card less? Okay, by the time we get to the river. And then what goes here? Well, I don't know, because if a heart came on the turn, then that should be 8, but if it didn't, then that should be 9. Which one do I put in here? Well, I don't know that. Okay, so that was the wrong way. What's the proper way of doing it? Well, what are my odds of making a flush? It is 1, which is certainty, minus my odds of not making a flush. What are my odds of not making a flush? Well, I have 47 cards, and then there's 9 cards that would make me a flush, so that means there's 38 cards left in the deck that would not make me a flush. And then I have this. Okay, and if I work this out, I get 35% of me making a flush on the river with 2 cards to come. Okay, hope you enjoyed. Thanks for watching.